First, I want to thank I4E, Gaiman, Carl, David Culler, and everybody for organizing today's events. It's great to have an entire afternoon on this project, and thank DRAS as well. I also want to mention the LB&L team. Scylla, raise your hand. Scylla and Ranjan. Ranjan is going to speak a little later on some of the modeling work. I'm going to speak for 5 minutes just to give you a really quick introduction about LB&L's role, and Ranjan is going to present some of the work a little bit later. So LB&L, I'm going to talk a little about OpenADR in a moment, but one of our primary roles in this activity was to work with the team on the OpenADR integration. We were involved in the simulation work, and one of the important things about the concept of the simulation is it allows you to look at the day-ahead prediction of the energy use given the weather, given the DR event, given the mass of the building, given how many people are in the building. So when you take the schedules, the price of electricity, and the weather, then the Energy Plus model puts those things together to help you develop control strategies that respond to the DR events. So Ranjan is going to present some of that work. And the baseline modeling issue that David just mentioned is one that we've spent a lot of time on also. And there's a lot of ways that you can deal with baselines. The baselines have to do with timescales of your performance predictions. So in a lot of the projects we do, PG&E will look at the last 10 days to compare how you did on one day with the previous 10. You can use weather regressions, or you can use models of how you would perform compared to some baseline. But in ancillary services, you may have an even faster need for baselines. You may have a real-time baseline tracking the performance against some baseline. OpenADR stands for Open Automated Demand Response. And in the picture here, essentially what's open is the application programming interface. It's an open API. OpenADR is a two-way signaling system, about 250 megawatts in California, currently being automated with OpenADR. So Cal Edison, San Diego, SMUD, and PG&E have automation servers. Automation servers are sending signals to buildings. Buildings have clients that are listening to those signals 87 year-round, every minute for a couple of years for many of the sites. I want to acknowledge George Hernandez in the back. Raise your hand, George. George was involved in our initial AutoDR demonstrations back in 2003. And I want to thank Alan Schroeder. Actually, David Hansen funded some of our work a few years ago as well. And Alan's here in the front. I also want to acknowledge Carl Besaw from SoCal Edison. He's on the board for the OpenADR Alliance. And I think Chris is gone. Chris Knudsen's also on the board for the OpenADR Alliance. So OpenADR is this client-server architecture that I mentioned. We have an open source toolkit. So OpenADR can be implemented version 1.0. We do not have a 2.0 toolkit yet that's open source. The API is open, but there is proprietary technology. Many of the server companies have proprietary servers to serve to the clients. It is done with a hardware retrofit, like the Siemens Smart Box is a hardware retrofit to get OpenADR signals to a control system, or you can embed the client in software. This is a quick timeline about OpenADR. George helped us back in 2003 in our initial trials. Ron Hoffman, who was here earlier this morning, was the one who conceived of the concept of OpenADR. Initially, we call it automated DR, but we added the word open to distinguish it from proprietary DR. What again is open is the open APIs. So it's built to be an interoperable system that allows utilities to send signals to control systems that use that API. It was built with the idea of allowing the state of California to go towards default dynamic pricing. On a hot summer day, if buildings saw higher prices, the theory was if they could automate the response, the grid would see a reduction in loads. There would be fully automated price response in as much of the demand side as possible, and we're actually starting to move in that direction. OpenADR is used in commercial, industrial, and residential buildings, and it is also being looked at for vehicles. In 2009, we published version 1.0 of the spec. It was published as an LB&L report with the California Energy Commission. And we gave it to the NIST Smart Grid standards process. In 2012, we have the formal specification of OpenADR 2.0, which is the national smart grid standard that's come out of the standards process that is the updated version of OpenADR that will be implemented in California next year. So many vendors are now building 2.0 clients, and 2.0 has formal compliance and certification testing that 1.0 did not have. So it is something that a utility can specify, and they can get their clients that they would buy control systems would be compliant OpenADR 2 systems. OpenADR is used around 8 countries around the world: China, Korea, India, Australia. There are deployments in Scotland, certainly through the West Coast, but we started west and we're moving east instead of the other way around. It is being subject of a lot of discussion in China and India, and we're working with some of the China smart grid standards activities. So that's it.